So here we're looking at page 9, which is a practice with drawing electron configurations. Okay, and so we've gotten to the point where we're able to use the periodic table without having to refer back to any of the the charts of orbitals or anything like that. So let's take a look. First thing we want to do with our sheet here is basically figure out how many electrons come in each one of these elements. So we look at magnesium, and all we got to do is find it on the periodic table. Atomic number is 12. That means 12 protons, which means we also have 12 electrons in the in the neutral atom. Now, how to build up our electron configuration. Basically, what we're going to do is add one electron one at a time and build up our electron configuration from the very beginning. So we start with one electron. Okay, one electron. If something has one electron, it's going to look like hydrogen, no matter what. Okay, it's going to look like hydrogen in the ground state. So the very first place we need to put our electron would be in the first energy level, and this is in the S block over here. So we start off at 1s. Well, that's only one electron, so we need to actually fill up our 1s, where we have 1, 2, okay, there we have it. The third electron makes the thing look like lithium, which again is in the S block, but this time it's at the second energy level. So we're going to start working on the 2s. We've got 2 more electrons there to get us up to a total of 4. The fifth electron here makes it look like boron, and that's now in the second energy level still, but it's also now in the P block, so we'd have a 2p. Now, how many are there in the 2p? 3 orbitals, so a total of 1, 2, 3, 4, 5, 6 electrons. That still only gets us to 2 plus 2 plus 6, 10 electrons. So let's add our 11th and 12th. The 11th and 12th electrons are in the third energy level in the S block. The 11th makes it look like sodium, the 12th makes it look like magnesium. Now we know that this is 3s2 because we would add 3s1 to get to sodium, 3s2 to get to magnesium. Okay, and so there's the electron configuration, the longhand electron configuration. Let's see how to do the noble gas configuration. For magnesium, we count backwards until we find a noble gas. That's not a noble gas, 11 is not. Number 10, neon, however, is. So we can say that this looks like neon with 10 electrons, except we've added another 2. So the 11th and 12th electrons, again, would add into the third energy level, the s orbital. So this would look like neon, 3s2. So let's look at the next one. Phosphorus has 15 electrons, so we add our 15 here. Now the beauty of using this system is that every single atom is going to use the same procedure, using the same pattern. So we can go ahead, 1s2, 2s2, 2p6. That takes us up to where we are at neon. Now we just need to add another 5 electrons. The next 2 add to the 3s, 1, 2. And the next 3 are going to jump over here to the p block. So 3p, third energy level, 1, 2, 3, and we've got 3 left. Now that we've gotten the full electron configuration, let's go ahead and write the noble gas configuration. So again, with phosphorus, we need to go back until we reach a noble gas, and that happens up here at neon. So phosphorus looks like neon, then needs to add an extra 5 electrons. The next 2, the 11th would make it look like sodium, the 12th would make it look like magnesium, so up to a 3s2. Then the 13th, 14th, and 15th are going to make it look like phosphorus. Those are in the 1, 2, third energy level. We're in the p block. This is 1, 2, 3 electrons in. So 3p3. Let's move on. Vanadium. Okay, so we've got vanadium here. Okay, vanadium number 23. So 23. All right, let's fold this down so it fits up a little bit. Okay, now we just got to count our way up until we hit 23. Start off again, 1s, 2. 2s, 2. We jump over here into the 2p, and that takes us up 6. That's 10 electrons. Now we look like neon. The 11th and 12th electrons in the 3s make it look like magnesium. And then 3p, 1, 2, 3, 4, 5, 6, makes it look like argon. Next, the 19th electron. We have potassium and calcium. Then, now here's the interesting part. This is the D block, but we're actually going to have to drop down one energy level. So from 4s to 3d. We go from 1, 2, 3. We do the ennoble gas configuration. We jump backwards until we hit argon. So this looks like argon plus 5 electrons. The first 2 go into the 4s, the next 3 into the 3d. Germanium, this guy here. So it's got 32 electrons, builds up with exactly the same pattern. 1s2, 2s2, 2p6, 3s2, 3p6. So let's run that again on the periodic table. 1s2, 2s2, 2p6, 3s2, 3p6. Okay. Now we jump down here. We're at 4s2 up to 20 electrons. We've got to go the entire length of the D block, which, if in case we forgot, we can count. 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3d10 gets us up to looking like zinc. We need 2 more. After 3d, we're in the P block. We're at the 4th energy level, so 4p, and it's 2 electrons in. Okay. The noble gas configuration would again look like argon, and then a 4s2, 3d10, 4p2. Let's try krypton. It's right down the row. So once again, it's got 36 electrons. We're going to take this up until it looks like zinc. Okay. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, till we're at calcium, another 3d10. Now, krypton is in the P block, okay? It's in the 4th row of the P block, so it's going to have a 4p. It's also 1, 2, 3, 4, 5, 6 electrons into the P block. The noble gas configuration would look like argon plus the rest of these electrons. So, argon, then 4s2, 3d10, 4p6. Okay. Next up, oxygen. A little bit more straightforward here. We're going to move it up since none of the other ones are all that long. Okay. So, take a look at oxygen here. Right there. It's only got 8 electrons. Only got 8 electrons. So, keeps it pretty straightforward. Start at the top. 1s2, 2s2, 2p, and let's count. 1, 2, 3, 4. 2p4. Noble gas abbreviation, we'd actually have to go all the way back. 8, there we go. Helium. Figure out what we add to helium. We need to add another 1, 2, 3, 4, 5, 6 electrons. Okay, so let me see that so you see that a little bit better. We need to add 1, 2, 3, 4, 5, 6 electrons to helium. The 3rd and 4th electrons that we can add to this thing are going to be in the 2s. The 5th, 6th, 7th, and 8th will be in the 2p. Manganese, right here in the middle of the D block, 25 electrons. I'll build it up till it looks like calcium. Okay, 1s2, 2s2, 2p6, 3s2, 3p6, and now we're back here to calcium in the S block, the 4th level, and we have 2 electrons to make it look like calcium. Manganese is in the D block, 4th row, but remember, the D block is 1 level behind. So, we're at the 3D sublevel, and we count over 1, 2, 3, 4, 5 to get to manganese. Its noble gas abbreviation starts with argon, and then counts forward. 4s2, 3d5. Only a couple more. We'll look at chlorine next. Chlorine up here. It's got 17 electrons, and its electron configuration starts off much the same way. 1s2, 2s2, 2p6 gets us up to looking like neon. Sodium and magnesium would add up the 3s2, and then we need to get to chlorine. So we add in the 3p, third row, p block, we add 5 electrons. Noble gas abbreviation would look like neon plus 3s2, 3p5. Go ahead and take a look at the last two, or last three, excuse me. Rubidium, potassium, and iron. Okay? Rubidium is here, 37 electrons. We're going to build this up till it looks all the way like krypton. 1s2, 2s2, 2p6, 3s2, 3p6. We're up here to argon. We skip down to the fourth row, 4s2, s block, 3d10 all the way across, and we're back into the p block here. So that's the 4p6 all the way across. Number 36, go to number 37. We add the 37th electron to make it look like rubidium. That is in the fifth row, s block, and we're in the first column. Noble gas abbreviation would just look like krypton. Here's 36 electrons. We add the 37th in the 5s1. Potassium up here. It's got 19 electrons. We're going to build it so it looks like argon. Now, the way we can tell this, argon is in the third energy level, it's in the p block, and it is in the 1, 2, 3, 4, 5, 6th column of the p block. So when I get up to argon, it should end up with a 3p6. We'll have one more electron to add. So 1s2, 2s2, 2p6, 3s2, 3p6. 2 plus 2 plus 6 is 10, plus another 2 and 6 is 18. We're at argon. Add the 19th electron. It's in the 4s, and there's only one of them. The electron configuration using the noble gas abbreviation would look like argon 4s1. Now, take a look at, we notice, potassium and rubidium right on top of each other. Look at what they add. They end 4s1, they end 5s1. There is a connection. We've talked about it today. We'll get into that a little bit later. Iron, last one here. Iron is in the D block. It is 1, 2, 3, 4, 5, 6 into the D block. First row of the D block, so we know it's 3D. Let's just go ahead and build it up all the way to 3D6. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Noble gas abbreviation would be argon 4s2, 3d6. Let's flip the page over. Now these are a little bit longer, so we're just going to look at the noble gas abbreviations for each of them. Okay? Look at the noble gas abbreviations. So here's calcium. Calcium right there. Let's go ahead and start. It's got 20 electrons. We need to start with the noble gas that comes before it. Count backwards, 20, 9 to 19, down to 18, argon. So it starts off with argon, and it adds another 2 electrons to argon. Argon's got 18, calcium's got 20. Those next 2 electrons have to go into the 4th energy level in the S block, and there are 2 of them. Lead is all the way down here. Okay, it's got 82 electrons, so I'm really glad we can use the noble gas abbreviation. 82, we're going to have to go all the way back until we hit, well, 82 down to 72, 57. What? Oh, right. 72, then we have to go down here into the F block, 71 all the way back to 58, then to 57, 56, 55, 54. There's our noble gas, xenon. So, it's going to look like xenon plus a whole bunch of electrons. Let's count up along the periodic table until we get there. Xenon. Then we add 6th energy level. It's in the S block, and there are 2 of them to get here. After the 6s, we actually go to a very strange place. We jump down here into what's called the F block. Okay? We jump down into the F block, and we're going to put this up here. Hopefully that's easy for you to see. Okay. We jump down into the F block where there are 14 electrons. So we go up into the 4F14. After we're done with the F block, we're into the D block again, 6S, 4F, 5D, and that'll end us up at Mercury. Remember, we can add 10 electrons into a D block, and that takes us up to Mercury. We've just got 2 more. After the D block, let's remind ourselves where this is. It's in the P block, 6th row, 2 columns over. So it should end with 6P2. Fluorine is up here. It's going to have 9 electrons. It will look like helium, and it has to add 2s2, 2p5. Rutherfordium's the last one. Rutherfordium is right here. Okay? It's in the 7th energy level, in the D block, so it's going to end with a 6D something or other. Okay? So it's got 104 electrons. Jump backwards until we get to a noble gas. Right there, radon. Let's add some electrons till we get there. 87 and 88 are in the 7th energy level, S block, so 7S. Then we're going to jump down and do all of the F block. 7S goes to 5F14, and Rutherfordium is in the 2nd row of the D block. Okay, second column of the D block. So it would end in 6D2. Last section here is on the rules of electron configurations, okay, which pretty straightforward. We've got Hund's rule, that's electrons are antisocial. The Pauli exclusion principle, if they pair up, there's only going to be 2, and the electrons are going to be spun in opposite directions. The Aufbau principle, electrons are lazy and will not skip any gaps. So in number 5, 1s, 2s, we're looking okay. 2p, both of these electrons are paired, okay? No good. Because electrons, if they have the option, are each going to take their own orbital. What would be correct would be something that looks like this. 1s, 2s, and then having our 2p, having those 2 electrons with their own orbitals. That is Hund's rule. Coming down to number 6, we see it skips 3s. Not good, okay? The Aufbau principle says electrons fill orbitals in order. Okay, Aufbau is actually from a German meaning building up, or something along those lines. So it wouldn't make sense to build the roof before you build the walls, which is what we've got here. In number 7, we've got 1s, 2s, 2p. That's a problem. That's a problem. We've got both of those electrons pointing the same way. Electrons with the same, we call it spin. That violates the Pauli exclusion principle. Lastly, number 8, do we see any problems with this? 1s, 2s, 2p, 3s, 3p, 3d. Oh no. What is supposed to come in between 3p and 3d? We're supposed to have a 4s in between there. So we'd actually get rid of a couple of those. Okay, that would get scratched out. My pen is too light for that to really show up, but it violates the Aufbau principle. We go 3p to 4s to 3d. Okay, that about covers it for our homework. This is the back of page